Hi, ladies and gentlemen. Today we're going to look at a couple of the SDQ questions together, just in case you need a little extra help. So we're going to start with question 1. So question 1 asks us to compare and contrast the structure and function of carbohydrates and lipids. So these are the first two biomolecules that we're looking at in class. So I actually didn't have an SDQ copy here, but that's okay. I just drew out the box. Remember, we have our claim, evidence, and reasoning. And you are first just responsible for this portion, so the claim, evidence, and reasoning portion. You don't need to do the revisions yet, and you don't need to do the questions part either, so we'll do that in class during the SDQ. So first one, we're comparing and contrasting lipids. So what I might do in my evidence base is just block them off, okay? So create two different sides. So we've been looking at lipids, and first we looked at carbohydrates. So I might use this as my carbohydrate space, since we looked at that first. So that was the first one we looked at for biomolecules. This is the second one, so we're looking at lipids. So I'm writing that down, and there's a few good places to start. So first I would get out for resources. So look at the POGL for lipids. And look at our notes, so from the screencast in class. So those would be two excellent sources. Okay. For carbohydrates, I would look back at, notes from class, and then maybe the chemistry of carbohydrates activity. So those are both excellent resources, so things to look at. You could also look here at the Carb Crazy. So that Carb Crazy article had a lot of information in it as well. So these are like our sources of information. So remember, for evidence, we're only looking at class sources of information. So let's start with lipids. So we said we were looking for structure and function. So structure. I'm going to flip back to that POGL. So look at that POGL. All right, find where it's talking about what the different lipids are made of. So if I look at structure, we have building blocks are the glycerol and the fatty acids. And I could try and draw from that first model on, from our very first model on the POGL, try and draw it out so it looks like it's like one big glob, so that's going to be my glycerol. Okay, I don't need all the details. And then we had, if we have a triglyceride, so we might have, this kind of looks like a jellyfish. Okay, here we go. So these are my fatty acid tails. All right, perfect. So I'm just drawing out what I see. So this is the general structure. So they can vary a little bit from this. So like phospholipids just have two tails. They have an additional section on the top. But this is our basic structure. Okay, so here we're starting with this. Then I'm going to look at additional pieces of information. So we could say can vary. So just what I said, can vary slightly. Okay, so we could have a phospholipid with, I'm just using abbreviations, with phosphorus. Or we could have, let's see, a cholesterol, which is a lipoprotein. So it's actually a combination of a lipid and a protein. So we have those two things, okay? And then it wants some information about function. So we're going to write function. Oh man, and I've got tons of things hopefully to list now. So function. If I look back at basic notes, it'll tell me about function. If I look at the POGL, it'll tell me about function. So a few things we listed, even just in our do now the other day, we said, so warmth or insulation. We said cushion. We said in one of the classes part of the cell membrane. We said, I'm trying to think of all of the wonderful things we said. Stored energy. I'm just going to EN for energy. And we said, looking at chemical Eric, we use them as, I'm just going to write a little bit into this other box, so no big deal if you have to do that. They are building blocks for, I made a little line I didn't mean to make, but that's okay. They're building blocks for hormones. So we need all of those things for this reason. So if I get out of the box, I can kind of box it in. No big deal. Okay? No big deal. So this is the information that I can find from my class activity. So that's what I'm writing there. Then I'm focusing on the other side. Oh, I missed a basic structure thing. So basic structure, we actually said that they were also made of carbon, hydrogen, and oxygen. But have very little oxygen. So generally speaking, they've got tons, so lipids have tons of carbon, tons of hydrogen, and just barely any oxygen. So we might be talking, a couple oxygen atoms in the entire molecule, and they're pretty big molecules. Okay, so we're leaving it at that, and then let's jump over to carbs. We'll start again with structure. So let's start with our chemical composition. So we have carbon, hydrogen, and oxygen. And we said that's about in a 1 to 2 to 1 ratio. So about. Okay, so 1 carbon for every 2 hydrogens for every 1 oxygen. So that's what we're looking at. We said that the building blocks are monosaccharides. Okay. And then we could have, a disaccharide was 2 monosaccharides. So a disaccharide is 2 monosaccharides. That's right, 2 monos, okay? A polysaccharide is many monosaccharides put together. Okay, so if we represent our mono with just one circle, then our disaccharide would be 2 of those circles put together. And a polysaccharide could be a whole, darn chain of them. So just tons of them connected. Okay, perfect. So let's look at function. So the primary function of carbohydrates is energy. So this is our body's primary energy source. So energy, this is quick energy for, we'll say, quick use or fast use. And short-term stored energy as well. And I'm going to write into this little space just a little bit. So we use them to store energy as well, okay? This is cellular energy equals glucose, a monosaccharide, so I write that. Okay, perfect. Just as a little note, because that's actually super important. So cellular energy, in order for the energy of any type, no matter its original source, to get into cells, it has to become glucose. So it has to be somehow transformed into glucose. So that's really, really, really important so that our body has energy. So I made some notes just based on what I've seen in class. So from notes from the chemistry of carbs activity on this side, I can also go back and look at that Carb Crazy article that we read in class and make a few notes from there. So now I have my evidence, and now it's time for me to move on to my claim and my reasoning. So generally what I do is I try to keep the claim super simple. So I'm going to write up here. Claim, keep it simple. Okay, so this one says compare and contrast carbs and lipids and their structures and functions. So I might write something like, okay, so carbs and lipids let's see, structure and function are made of the same elements, but they have very different molecular structures and functions. Okay, done. So I'm just leaving it at that. For the reasoning, then I'll go into detail, and that's where I'll say, okay, so maybe maybe carbohydrates have more of this 1 to 2 to 1 ratio, where lipids have, very little oxygen, even though it's still present. I'll explain some of the differences that I noted in my evidence section. So I'm just explaining it out in writing, okay, instead of a list or drawings. And I actually really like having drawings, so if you want to go for drawings, then that's great. Okay, so quickly, I'm not going to do that part for you, so I want you to practice that. So just rewording what you put here in your list, in your notes, okay, into sentence structure. So now let's look at one more. I'm trying to scoot this up. So again, I did say I did not actually bring an SDQ to my house, so I'm just going to draw out the boxes. Okay, so it looks something like this. Okay, I didn't use a straight edge, but here we go. So drawing out the sections. And let's look at question 4. Okay, so we'll do question 4. And this was actually, just as a reminder, this is supposed to be question 1, so help with question 1. Okay, question 4. So looking at question 4, we have our claim, we have our evidence, we've got our reasoning. So let's start with our evidence, as usual. So this one describes, oh my goodness, I don't have it to read. It describes 2 people's cholesterol, so my cholesterol and Mr. Southwell's cholesterol. So actually, I'm going to pause and make sure I can read that out. So let me see. Let's see if I can find it here real quick. So I'm looking at my computer, and I know you're just staring at the sheet of paper next to me, but that's okay. So this one says, Mr. Southwell and Miss Weisberger had their cholesterol tested. They both had a cholesterol level of 160. Okay, so they both have, making a note of this, both have 160 milligrams per deciliter. This would be total cholesterol. So I'm just making a note. So we got some information already just from our question. I'm just going to note it there. Okay, so Southwell's. Okay, Mr. Southwell's HDL equals 48, and this would be milligrams per deciliter. Mine would be 65 milligrams per deciliter. Right, and that says, based on the data, who has better cholesterol? So this is where we really need to go back and take out that blood cholesterol reading, so that article, because it had all of those data tables on it, and the data tables told us about the levels and which levels were good and which levels were considered dangerous for the total cholesterol as well as for the HDL. Oh, I should note here, this was HDL for me. Okay, perfect. So I would grab those. And once you have them, we're going to flip to that page. I don't have it on me, so you got to take a look. I think it's like the 3rd page or the 2nd page of the article. So we're looking at those data tables, and it tells us about total cholesterol. So we want to make some notes about total cholesterol levels. So if we look, a total cholesterol, according to the data table, and I'll write here, I'm just going back to my blood cholesterol article. So that's what I'm looking at. Okay, blood cholesterol article. So total cholesterol. That is less than 200, oops, ate that other one. 200 milligrams per deciliter is ideal or good. Okay, good. Oh man, I'm eating some letters here. Better focus a little bit. So total cholesterol less than 200 milligrams per deciliter is considered